Alright, so the last linear programming model that we will discuss is the 0-1 linear programming. And here the decision is to either have a project or not. And the question is not shall we have 3 or 4 or 5 projects, but the question is shall we have 1 or 0. And that is particularly relevant for projects related to public infrastructure development. So let's say a city or region, they may want to think, shall we build a new hospital or a new museum or a new school or a new university or a sports event place. So the question is not, do we need 3 more bridges or 5 more stadiums, but shall we do it, yes or no? So the problem that we have here is, so 0-1 integer programming is concerned with finding the optimum selection of binary alternatives. So consider the following example. A professor can choose between 4 projects to be conducted over the month of January, February, and March. These projects are finishing a research project, R, preparing lecture notes or teaching, T, applying for a consulting project, C, and providing a service to the department, S. Each project has a payoff measured in bonus points for the annual review process. Below table summarizes the payoffs, the monthly hours necessary to complete the project, as well as the available hours per month. So obviously solving a linear programming model with 4 decision variables is now graphically impossible, and we need to again rely on Excel solver. Okay, so in order to code that, what we need is this information here, and then we just convert it into a linear programming model. And so what we do is we basically copy the table, and we always start with the decision variables. And the decision variables are research, teaching, consulting, or service. Let's make that a little bit bigger. And now in the next row you have the optimum decision parameters, and you know those will be the one that Excel will choose. Optimum decision maybe values. So again, this is 0-1. And we have a payoff function. That is my objective parameters. So here I will put the points that I get from completing one project. So if I do a research project, that's 200. If I develop another course, 150, 150. And then let's do next the constraints. That is my time, so January, February, and March. And okay, Okay, so in order to complete a research project, I need 50 hours in January and 20 of each in February and March. If I want to prepare a new lecture, I have 40 hours in January, 30 and 10 in February and March. For consulting, 30, 40, 30, and for service 20, 10, 20, 20, 10, 20. Let's double check if everything is correct. 200, 150, 150, 50, 20, 20, 40, 30, 10, 30, 40, 30. Okay, so this is pretty much all that we need to input. So let's put that up again a little bit. And let's maybe create a little bit more space here now. So these numbers, they all need to be input, so we can make that a cell style, call that input. And that is a cell style input. Of course, you can style it any other way. And here, research, teaching, consulting, and service, this is what Excel will determine. So we can maybe, that this might be an output. So now we still need to add the constraints and the various formulas. So for the objective function, so that is my total profit that I want to maximize. And here I can use again, I can do it one by one. I can say this is this. So the optimum number of research projects time the payoff plus the optimum number of teaching projects time the teaching's payoff plus the optimum number of consulting projects times the consulting payoff plus, okay. And then if I just double check the numbers now quickly, say 1, 2, 3, 4, I can see, okay, now I get 1,000. But the way I enter the formula, it's a little bit cumbersome. So there's a shorter way, and that is the formula sum product. Sum product. And that sums up products. And this will be the first array. And the second array will be from, in my case, C to F4. And in the first one, it should be C3 to F3. And then this should also give us 1,000. So what this formula does, it multiplies first this times that in the array. So the arrays must have the same length. Plus 2 times 150 plus 3 times 100. So that's a little bit of shortcut. Okay, so then we need to go to the constraints and we need to calculate the total usage. And now I use again the sum product formula. And the first array is again C3 to F3, which is where I have my optimum decision variables, but I fixed them with F4. And then I multiply it with my first constraint, the hours that I need in order to complete the various projects. Okay, and now, because I fixed the cells from C3 to F3, the optimum decision variables that Excel will define, I can just copy down that formula. And you see, if you look, for example, at the March row, it multiplies 1 times 20 plus 2 times 10 plus 3 times 30 plus 4 times 20. But anyhow, let's just reset everything to 0 in the optimum decision variables, and let's define the objective function. Maybe that is a calculation, and the total usage, that's a calculation too. And then continuing with the constraints, we next have the sign, and the sign is always less than or equal. And then we still have the maximum time, maybe for each month. Let's see if we can fit that a little bit to content. So the maximum time is 120, 80, and 60. And yes, this is again a given, so we make that indeed a cell style that says this is an input. Okay, so now we have everything, and we should be able to run that model. And again, what we need to make sure is that we go to data analysis, the data analysis solver, solver. And so I want to maximize. My objective function is in cell G3 by changing the cells from C3 to F3. My constraints, add, and I use here the shortcut that I click into the first cell, and because they all have the same sign, less than or equal, I can just drag them down. And that constraint needs to be less than what I have in column I, 6 to I8. And I just say OK. Then I want to make the unconstrained variables non-negative, and I select again simplex LP. Well, so now if I click, for example, on solve, I get the result that I'm supposed to do 2.4 research projects, which is of course nonsensical. Because let's say if that is part of my annual review process, nobody would round that up and say that I did 3. So we can do integer solution, but if we do the integer solution, what we would have to do is we add the constraint, and we would say that the optimum decision values that Excel is supposed to be an integer. That's what we did for the integer solution. And if you click now OK, and I solve, then the optimum would be to do 2 research projects and 1 service. But again, I can't do really 2 research projects. So I need to limit it to doing either 1 or nothing, because I have only, let's say, a good idea maybe for 1 paper. So in order to add this constraint that we have either 0 or 1, we have to add the binary constraint. And so we remove the integer constraint, and we add the new one saying that the optimum decision values, they are supposed to be a binary, and we add this. And okay, so we added the binary constraint, and then we solve. And then the optimum solution would be to have 1 research project, 1 teaching, no consulting, and 1 service. Okay, and here if you go to the slides, you can see again what it looks like, and you can look up again the additional constraint that you need to add, which is the binary, and yeah, that would be the optimum solution. So the most important thing is that you understand how to set up a linear programming in Excel. You also can solve at this point now a linear programming model graphically if you have only two decision variables, but once you go beyond two decision variables, you need to have a program like Excel solver. Okay, let's just stop here and then let's continue with some more problem sets and just review again some of the material we just covered. So let's just stop here and I'll see you when we go over some problem sets.